All right, today we are talking about tangents and their relationship on a circle. This is 10-5. Okay, so when we talk about tangents, we have two different theorems that we're looking at here. Okay, so the first theorem says if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Okay, so the first thing that we have to look at here is our tangent line. Okay, if you remember, our tangent line is a line that intersects the circle at exactly one point. So on this circle, our tangent line would be this line right here. That's on the outside of the circle. Now, our radius, remember, starts from the center and goes to the outside of the circle. So technically we have this radius and we have this radius. Okay, but we're looking for the radius that intersects the line that is tangent, which means we are looking at this first line that I highlighted. Okay, so that is the radius. Alright, so if the pink line is tangent to the circle, then the radius drawn to that point of tangency is perpendicular, which means it forms our 90-degree angle. Now, our point of tangency here is obviously where our tangent line hits the circle. Alright, and that would be this point right there where the two intersect. Okay, now we're going to use this a little bit later on. Okay, but now we have a right triangle, which means we have a triangle that we can use Pythagorean theorem on, and if you'll remember, we have A, B, and across from our 90-degree angle would be our hypotenuse, which would be our C, and that's going to come up in a little while. Okay, our second theorem says that if two segments come from the same exterior points, are tangent to a circle, then they are congruent. So here's that point. So this point, right, the exterior point is on the outside of the circle, are tangent to a circle. So we have two different tangent lines that we're looking at here. We have a tangent line from here to this point, and we have a tangent line from that exterior point to this point on this side. Okay, so if those two segments come from that point that is on the outside, then they are congruent. So then this segment would be equal to this segment. So we could say, like, if this was 15, then this segment would also be 15. Okay, so let's look at some examples. Okay, this first example, we have these lines that we're talking about. Okay, and if we look here, it says line blank is tangent to circle S. So what we need to look at is which line is tangent to circle S. Okay, and our line that's on the outside would be this line right here. Okay, now there's a couple different ways we can name this line. They put that lowercase l, so we could say line L. Okay, we could also use any two of the capital letters that are on that line. I'm going to just call this line YX. Okay, and I just want you to put the L in parentheses, that way you know that it could be called line L. Is tangent to circle S if and only if that line, that line YX or L, is perpendicular to the radius, and our radius would be ST. Okay, so if you look here, we've got the measure of angle STX would be 90 because it's a radius and a tangent line. And your point of tangency would be point T. Okay? Now, our example for our second theorem, says if QP and RP are tangent to the circle C, then blank. Okay, that blank just means that if our lines, this line and this line, are tangent, which they're both tangent, they only hit the circle at one place, and they come from the same exterior point, then we know that those segments would be equal. So we would know that QP is congruent to RP. Okay, so QP is congruent to RP. Alright, so these next examples we get into actually using the numbers and figuring out what we're finding and all of that stuff. Okay, so it says that MC and MZ are tangents to the circle. So we know that we have tangent lines. Okay, so we are looking at number 1, which says find the measure of angle BCM. Okay, so the measure of angle BCM, okay, means we're starting at B, going to C, and ending at M down here. Okay, now that angle is made up of BC, which is the radius, and CM, which is tangent. Okay, which means that if BC is the radius and CM is tangent, that it is a 90-degree angle, which means it's 90 degrees. Okay, the number 2 we're looking at, they want us to find the length of CM if CM is 5x minus 9 and MZ is x plus 7. So if we look at CM and MZ, CM is right here, and MZ is right here, and we know that both of those lines are tangent. So we know that CM equals MZ. So we would just say 5x minus 9 equals x plus 7. And then you would just solve your equation for x to start. So we would get 4x minus 9 equals 7. Add 9 on both sides, and we would get 4x equals 16. Divide by 4, and we end up with x equals 4. Okay, but we're not quite done because they wanted us to find the length of CM. So to find CM, we just have to go and plug that back in and say 5 times 4 minus 9, which would give you 11, and that would be your final answer. Okay, so moving right along, okay, number 3 and number 4 are a little bit different, and we're going to look at using some triangles here. Okay, we're still using the same picture that we used for number 1 and 2. Looking at number 3, they want you to find the length of EM if CM is 12 and BC is 5. Now, as previously discussed, we know that this angle at C is a 90-degree angle because it's a radius and a tangent that come together. Okay, so if we're looking at this, they want us to find EM, which is this part right here. Okay, but we can't just find EM from the start. We're going to have to find BM first. Okay, so to find BM, we have this triangle, this right triangle. Okay, and on our right triangle, we've got 12, and we've got 5, and we're missing this side over here, which would be BM. Alright, so this would be BC and M. So to find this piece, I'm going to call it X, we would need to do Pythagorean theorem. So we would say 5 squared plus 12 squared equals x squared. So 25 plus 144 gives us 169, and then the square root of 169 is 13. So x would equal 13. Okay, so this whole side, BM, equals 13, but we are looking for EM. Okay, now what we also know, okay, we're trying to find this segment right here, is that BE from here to here is a radius, and BC was also a radius, which means BE is 5. Okay, so to find EM, we would need to say 13 minus 5, which would give us 8. Okay, so make sure that you're going through all those steps to get to the answer that we are actually looking for. Alright? Now the second one is similar. We're still going to use a triangle, but they give us a little bit different information here. Okay, so on number 4 it says if the measure of angle CBM is 60 and CM is 13 square roots of 3, then they want us to find the length of BC. So we're still looking at a triangle here, okay, but on our triangle, we still have C is at our 90-degree angle, we've got B over here, and we've got M at the top. Okay, and they tell us that angle CBM is 60 degrees. So this angle right here is 60 degrees. We know that angle C was 90, which automatically tells us that this angle up here has to be 30. Okay, now we also know, they told us right here, that CM is 13 square roots of 3. So we're going to put 13 square roots of 3 right there. Now, we had to think back on this, okay, 30, 60, 90 triangles. We've got our boxes, okay, and if you'll remember, we used M in the middle, 2M, and M square roots of 3. Now, our M was across from our 30-degree angle, our M square roots of 3 is across from 60, and 2M is always across from 90. So we have to figure out which piece did they give us, and they gave us this 13 square roots of 3, which is across from angle B, which is at 60. So we know that 13 square roots of 3 goes in our 60 M square roots of 3 box. Okay, now remember to go from M square roots of 3 to M, we are dividing by the square root of 3, which gives us just 13. And then to get 2M, we have to multiply times 2, which would give us 26. Okay, now the piece that they wanted us to find was BC, and BC is right here, and that's across from your 30-degree angle. So the piece that we wanted was right here, which means that BC equals 13. Okay, so taking what we know and applying it to get to that final answer that they're asking for using tangent lines. Okay, we've got 2 more examples that we want to talk about here real quick before the last section. Okay, find the length of CM if BC is 12 and BM is 20. Okay, so BC is 12. Okay, BM is 20, and they want you to find CM. I'm not going to work this whole problem out, but we are again using that triangle. Okay, we've got C, we've got M, and we've got B. We've got BC is 12 and BM is 20, and we're looking for CM. So again, we're using Pythagorean theorem, and we have to subtract. So we would say 20 squared minus 12 squared equals x squared. After you do that work, you should end up with x equals 16, which means that CM equals 16. Okay. Now the last one is on this other triangle. Okay, we want the length of, we want to find the length of XE. Now XE is this whole segment right here, which would be called our diameter. Okay, if BM, okay, B to M is 25, and Z to M is 20. Now, if we want the diameter, then what we need to find is the radius. So we actually are going to find this segment BZ first, and we know that BZ is a radius and ZM is a tangent, so that's our 90-degree angle. So we've got this triangle, Z at our 90-degree angle, okay, M at the top, and B at the center. We know that BM is 25, and ZM is 20, and we need to find that radius first. So again, we're using Pythagorean theorem, and we would say 25 squared minus 20 squared equals x squared. Okay, if you do that math, then you end up with x equals 15. Okay, but we're not done, alright? BZ is 15, which is your radius. So if the radius equals 15, then to find the diameter, which is our XE, then we double it and we get 30. Okay? So those are our main examples. I want to go through just a couple more with you here real quick. Okay? These are similar to what we were just talking about, but they're just set up a little bit different. Okay, on these first ones, we are assuming that the segments appear to be are tangent. So if we look here, we see that BC is tangent and CD is tangent, which means we know that they're equal. Okay, which would just mean that we have x plus 3 equals 7. And so to get x, all you would have to do is subtract to get x equals 4. So just don't make those more complicated than they have to be. Okay, and then number 2 has that Pythagorean theorem looking one. Okay, JK is our tangent and JH is our radius, which means our 90-degree angle goes in at J. Okay, which means we are finding the hypotenuse, which means we would just say 15 squared plus 20 squared equals x squared. Okay, and that is actually one that was similar to one that we did earlier, right? We would get 225 plus 400 equals x squared. And the square root of 625 is 25. So 25 equals x. Okay, now the last thing we do need to talk about with tangents is this thing that they call circumscribed polygons. Okay, and what that means is when a polygon is circumscribed about a circle, then all of the sides of the polygon are tangent to the circle. Okay, so you can kind of think of it as we're drawing a circle inside of a polygon is what we're looking at. Okay, now what they're talking about is that all of the sides are tangent to the circle is this. If you look at this first example, okay, they come from the same exterior point. So this side and this piece right here would be the same length. Okay, so we see that this side is 17, which means this side would also be 17. Okay, so the same thing happens over here, that if this piece is 10, then this piece that it comes to the same point would also be 10. So to find x here, we would say 13 plus 10, which would be 23. Okay, then your other piece here is that if this piece up here is 13, then this side would also be 13. Now if you remember, when we talk perimeter, that means we're just adding up all of our sides. So we would say 17 plus 10 plus 10 plus 13 plus 13 plus 17. Okay, when you add all of those up together, you end up getting 27 plus 23 plus 30, which gets us to 80 is our perimeter. Okay, now the next one I wanted to do with you is just number 3, and it's the same idea. Okay, if this piece right here is 8, then this piece right here is 8. Okay, this whole thing was 16, so if this top part was 8, then this bottom part also is going to be 8. Okay, which gives us 8 over here, and then you could continue on. Now, if we're looking for x, okay, then our x piece is right here, this 2x, and that segment is equal to this segment on this side because they're tangent. So we would just say 2x equals 8, divide by 2, and x equals 4. Okay? So the other thing you know is that if this side is 16, then this side has to be 16, which means this is 8, which then tells us this is 8. So if we were going to find the perimeter, okay, this is actually a square, and we could say 4 sides times 16, which would end up giving us 64. Okay, so with tangents, we have a lot of triangle stuff. Make sure that you're just being careful on these types of problems and not going too quick. Good luck with tangents.